Ever wonder what makes your computer more than just a box of circuits? Well, today we're taking a guided tour of computer peripherals, all the essential gear that brings your digital world to life. From the keyboard you're typing on to the monitor you're looking at right now, we're going to explore how these devices work and why they're so crucial for unlocking a computer's true power.
Yeah, this cartoon kind of nails that feeling, right? Sometimes it seems like we're drowning in all the stuff we connect to our computers. But don't worry, we're about to break it all down and show you how every single one of these peripherals plays a vital role in the bigger picture.
Okay, so let's get official for a second. What exactly is a peripheral? Well, it's pretty much any component that's external to the core processing function. Think of the CPU and main memory as the computer's brain. If that's the case, then peripherals are its eyes, its ears, its hands, and its long-term memory. They're what let that brain actually see, hear, and remember anything.
So here's our game plan. We'll kick things off with something called the storage hierarchy. It's a super important concept for understanding how your computer handles data. Then we'll dive deep into storage devices, displays, and printers. After that, we'll look at how we talk to the computer, and finally, we'll pull all the pieces together. Ready? Let's jump in.
First up, one of the most fundamental concepts in all of computer architecture, the hierarchy of storage. It all comes down to a really simple but unbreakable trade-off. You can have your storage be fast, big, or cheap, but you can never ever have all three at once. Let's find out why. This table lays it all out. At the very top, you've got CPU registers. They are practically instantaneous. But to give you a sense of scale, let's try an analogy. If getting data from a CPU register took just 1 second, getting that same data from main memory would take about 5 minutes. And from a hard drive, you'd be waiting for almost 3 weeks. That massive difference is exactly why this hierarchy exists.
So here's the bottom line. The faster the storage is, the more expensive it is for every single byte. And that trade-off is precisely why your computer is this complex mix of different storage types. It uses a tiny amount of super expensive blazing fast memory for what it's working on right this second, and then it uses massive, cheap, and slower storage for everything else it needs to remember.
So, pretty much everything below conventional memory on that pyramid we just saw falls into this category, secondary storage. Its most important feature is that it's non-volatile. That's just a fancy way of saying it holds on to your data even when you turn the power off. This is the permanent home for your operating system, your apps, and all your files.
All right, now that we get the why behind secondary storage, let's take a closer look at the actual physical devices that make it happen. This is where your digital life, your photos, your schoolwork, your games, all of it actually lives.
And here it is, the classic modern matchup, SSDs versus HDDs. Solid-state drives are purely electronic, no moving parts. This makes them ridiculously fast. It's the reason a computer with an SSD boots up in just a few seconds and everything feels so snappy. On the other side, you've got the veteran hard disk drives. They're mechanical, which makes them slower and a bit more fragile. But they still have one big advantage. They offer huge amounts of storage for a much, much lower price.
And this image right here shows you exactly why a hard drive is slower. Just look at all those moving parts. You've got a platter that spins thousands of times a minute and an arm that has to physically race a little head to the exact right spot on that disk. All of that physical movement takes time, creating a speed limit that purely electronic storage just blows right past. Let's break down that little mechanical dance. First up is seek time. That's the delay while the arm moves the head into position. Then comes rotational latency, where you literally have to wait for the disk to spin around to the right spot. Only then, finally, can the data actually be transferred. Each of those steps adds milliseconds of delay, which is an absolute eternity to a CPU that operates in nanoseconds. Okay, so we've covered how data gets stored. Now let's switch gears and talk about how we get that information out of the computer and into a form we can actually use. How do we see it, watch it, or even hold it in our hands? Well, that's where displays and printers come in.
Let's quickly break down the screen you're looking at. Any image you see is made of millions of tiny dots called pixels. Resolution is just how many pixels are in that grid. More pixels means a sharper picture. Color depth tells you how many different colors each one of those pixels can display. And the one running this whole show, the conductor of the visual orchestra, is the graphics processing unit, or GPU.
You know, to really appreciate what a modern GPU does, just look back at a game like Pong. The graphics were just a couple of white blocks. The main CPU could handle drawing that and running the game at the same time, no problem.
But a modern video game, it has to calculate the color, lighting, texture, and position for millions of pixels, and it has to do it 60 times every single second. That is a mind-boggling amount of work, and it's why we need a powerful, dedicated GPU to do all that heavy lifting.
Laser printers honestly feel like magic, but it's really this brilliant process. A laser uses static electricity to draw an image on a drum. That static charge then acts like a magnet for powdered ink, which is called toner. The paper rolls up against the drum, the toner image jumps over to the paper, and then a super hot roller melts and fuses it permanently onto the page. It's an incredible little high-speed process.
This question is a perfect lead-in to the other main type of printer, and the answer is a huge, emphatic yes. Inkjet printers have their own kind of magic. Imagine a super precise spray painting process. Tiny nozzles, way smaller than a human hair, boil a little bit of ink, which creates a bubble that shoots out a microscopic droplet with amazing accuracy. By firing millions of these tiny dots of different colors, it builds up a photograph with stunning detail.
So we've covered storage and output. Now we're at the final, crucial piece of the puzzle, input. How do we, the users, tell the machine what to do? How do we get our ideas and our data into the system in the first place? This is the world of keyboards, mice, and touchscreens. And here are the greatest hits of input devices. You've got keyboards for typing and pointing devices like a mouse or a touchpad to get around. It's funny, the very first computer mouse was actually a clunky wooden box with metal wheels inside. And of course, input also includes all the devices that help us digitize the real world. Things like scanners for documents, microphones for our voices, and cameras for images.
This is a fantastic example of how much optical input has evolved. On the left, you've got the familiar barcode you see at the grocery store. It's one-dimensional and can only store a few numbers. But on the right is a two-dimensional QR code. By using that whole grid of squares, it can store a huge amount of information, over 4,000 characters. That's why it can do so much more, from taking you to a website to processing a payment.
All right, let's bring it all home. We've looked at storage, output, and input devices one by one. Now let's just take a step back and see how they all connect to create the complete, functional computer systems that we use every single day.
So, what are the big things to remember from all this? First, peripherals are everything that connect the computer's brain to the outside world. Second, they all fall into one of three jobs: input, output, or storage. Third, that all-important storage hierarchy forces that constant trade-off between speed, cost, and size. And finally, every single one of these peripherals is a seriously complex piece of tech that, altogether, is what makes a computer a useful tool.
And we'll end on a question to chew on. Your graphics card has thousands of its own processors. Your phone has a dozen different sensors. As these peripherals get more and more powerful in their own right, that traditional line between the central computer and the things we plug into it gets blurrier every single year. It really makes you wonder what the computer system of the future is